Today's episode is proudly sponsored by the Rising Tide Mastermind. The Rising Tide Mastermind is one of my favorite things that I look forward to each and every week because I get to see people that have my best interest in mind. I know this because I have their best interest in mind. And when you get people together in a room like that, you can just imagine how people want to help other people. If this sounds like something you want to learn more about, go to scalinguph2o.com/mastermind. Welcome to the Scaling Up H2O podcast, the podcast where we scale up on knowledge so we don't scale up our systems. I'm Trace Blackmore, the host of the Scaling Up H2O podcast. And happy Friday, Scaling Up Nation. Of course, we bring a new episode to you each and every Friday as our free gift to you because you are out there doing so much for the industrial water treatment industry. And today is one of my favorite types of shows. That is where the listeners in the Scaling Up Nation write into me and ask me questions to answer. And of course, we call those very fondly Pinks and Blues episodes. So there you go, Scaling Up Nation. Today is a Pinks and Blue episode, and I cannot wait to start answering your questions. But we are going to have to wait just a moment because I want to tell you about some things that are going on. One that we've started talking about is the Global 6K for Water. That is taking place on May 18th. And you might be asking, where is that taking place? Well, it can take place wherever you want to walk or run a 6K. You do not have to be any particular place in order to observe this 6K, in order to participate in this 6K. And why is it a 6K? Because that is the average distance somebody that does not have access to clean drinking water has to walk to go get water. And folks, a lot of this water that they are collecting is water that you would not want to drink. Now, while they're walking 6 kilometers, they are in areas that are not very safe and bad things can happen to these individuals, as well as they are not in school. Mostly it's children that make this journey. So they're not in school. They are not preparing for their future, and that's not preparing for the village's future. So by just bringing water to where people reside, it changes everything. Now, the goal is that we can end the global water crisis within our lifetime. And that means that everybody has access to clean, sanitized drinking water, and it is right where they are. And because of that, they are not having to take extra time out. And it's not an organization. Now, Team World Vision is who we are talking about that puts on the 6K. They don't simply say, hey, folks, here's a well, you figure it out. No, they go in, they train people, they give ownership to the people that are going to get the benefit of these wells so they understand how they work, how to repair them, how to continue to use them. And they do that with every donation they get of $50. It's amazing what they can do with $50. So if you're interested in the 6K, and I hope that you are because we need you out there, you can go to scalinguph2o.com/6K and you can register in a couple of different ways. One, if you want to join your own team and you want your office to do it, you want your company to do it, by all means, use that link and make your own team on that page. And you'll get all this information from Team World Vision to make this very easy for you to accomplish. And you can do that again by going to scalinguph2o.com/6K. But maybe you just want to do this on your own. Well, if that's you, I invite you to join Team Scaling Up Nation. And that's the page that it will take you to. And you can sign up there and know with your donation of $50, you are bringing water to at least one individual. And you're also going to get your entire racer's kit, which includes a t-shirt, a bib that will have the person you are sponsoring, a medal, and all sorts of information about Team World Vision. It is a great organization. I know when you read more about it, you're going to see why we are so happy to support it. And we've been doing this for a couple years with the Scaling Up Nation, and hundreds of people now have access to clean drinking water because of the Scaling Up Nation. I am so proud of that. And I know that this year, we're going to blow past years out of the water, pun intended. All the information you need is at scalinguph2o.com/6K. And Nation, it is a fun thing to do because you can go wherever it is convenient for you to go. You can have a great conversation with your teammates, with your family. And as you are doing this, you are educating people that are going to ask, hey, why are you wearing these bright orange shirts? And why do you have this bib on that shirt of a young child? You now get to educate them about the global water crisis. And through education, we can make a difference. Through these actions, we can make a difference. And I sure hope you choose to take action on this. Once again, scalinguph2o.com/6K. Nation, here are a few more events that you might want to put on your calendar. The Emerging Water Technology Symposium is taking place in Paradise Valley, Arizona, May 14th and 15th. This is where several organizations come together to put on this symposium. And that, of course, is the American Society of Plumbing Engineers, Plumbing Manufacturers International, and the World Plumbing Council, along with our friends at IAPMO, which is the International Association of Plumbing and Mechanical Officials. We've had a couple of people from IAPMO on the Scaling Up H2O podcast. This is an event that's going to discuss all things plumbing and water distribution, along with water efficiency. So for more information on this, you can go to our events page, and we will have everything you want to know, as well as a link to go directly to register for that event. While you're there, you can also check out the International Water Association. They're having their Sustainable Sludge Management Conference in Beijing, China, May 17th through 20th. We'll have all of that information on our events page. The 2024 ASHRAE Annual Conference is taking place in Indianapolis, Indiana, June 22nd through 26th. So those are just a few things going on, but you will see everything that is going on by going to scalinguph2o.com, going over to our events section, and anything that we know about within the industrial water treatment community, we are going to have on there. Nation, I mentioned at the top of the show, this is one of my favorite shows because it's all about questions from the Scaling Up Nation. And what we've done here, what the great team of Scaling Up H2O has done, is put a compilation of all questions around this particular topic together, and we're going to try to make a show out of it. So one listener wanted to know, what do you need to know when you are collecting a sample for analysis? And of course, there's all different things that we can collect as industrial water traders, and there's all different tests that we can run. So we're going to go over a few of those to see if we can maybe help you the next time you are collecting a sample, and maybe there's some things that you have not considered. So the first thing that I want to start out with is you have to know what you're analyzing. And I know that's a silly statement. Of course, you know it's water. Of course, you know it's scale. Of course, you know it's a section of pipe. But by knowing that, and also knowing all the things that are around that, you are now able to get valuable data that you have access to right now in this point in time that you will not have later. So think about that. You're going to get that report maybe weeks, months later. And then how are you going to interpret that? So all of these things that we're going to talk about are context clues that are going to help with your interpretation. So say, for an example, it is corrosion from a piece of pipe. Well, what do you know about that piece of pipe? How is it connected? Is it connected with another type of pipe, maybe a different metallurgy? Is there a dielectric union involved? Is there maybe some sort of grounding wire that's connected to it? Maybe take some pictures from up close so you can see where that sample is coming from, but then also further back so you can get even more context when you're trying to figure things out later. Right now, you are able to very easily collect data that won't be as easy later when you're trying to figure out what that report means. Now, maybe it's a water sample, and you're thinking, okay, well, we're water treaters. We take water samples all the time. What do we need to know about that? Well, one, is that sample truly indicative of what you're trying to collect? Now, think about you're taking a water sample off of a leg that goes to a faucet, and let's say that's about 100 feet long, and nobody ever uses that faucet. Well, folks, you're not getting the sample you think you're getting. You're getting the sample what's inside the pipe, but it's not what the actual system is seeing. So you want to make sure that you're flushing everything through. You are getting a good sample. And then you need to make sure you are very sure that the sample you are collecting is really the sample you think you are collecting. And then what type of sample is that? Is it a wastewater sample? Is it a cooling water sample? Is it a softener sample? Realize some tests that you're going to ask labs to run, you can't just send a water sample. You need to prepare that sample somehow. Think about if you've ever taken a Legionella sample. There's a thiosulfate tablet in the bottom of that to get rid of any oxidizer, so you're actually getting the sample as it resides, not as the sample sits alongside oxidizer as it's in transit. So that's an example of a way you might pre-treat, but there might be something else that you have to pre-treat with. So don't assume that every single sample is the same. If you're working with a particular lab, make sure you know if there's a specific bottle, if there is a specific pre-treatment that needs to go in that bottle. So when you send that sample off, you can get the best result back. Don't assume, always ask. And when you go in there to just take a sample, don't think about it as just taking a sample. Have your procedures with you. Know that everything that you're doing is correct and you've mentally done it before you actually do it. So that way you can answer a lot of questions before actually being on site. You might realize that you've got to go by the laboratory and pick up a particular bottle instead of going to the site, grabbing a sample, and then the lab telling you, I'm sorry, we can't accept that. That's not in the right bottle. It hasn't been treated right. And now you've got to go all the way back. A little bit of time invested in the front of whatever sample you're trying to collect, I promise will pay off in the long run. Now, with water samples, is it a grab or composite? That was a question that somebody asked that wrote in. What exactly does that mean? Well, think about it. If we're going in and we're taking a water sample, so let's say like a Legionella sample, typically you want to go ahead and take that sample immediately of what's coming out of the faucet because that's what somebody is going to see. So that would be a grab sample. A composite sample, and the example that I can think of is a water softener. Say you're having an issue with a water softener and you're trying to figure out when this water softener is becoming hard, when it's no longer producing soft water. So you might have a sample over a 24-hour period drip into a 5-gallon bucket or some other vessel. And then at the end of that sample collection, you're going to test that sample for hard water. And you're not going to be able to tell exactly what time frame that happened in, but you will be able to limit it down to maybe a particular time during the day, because that's a composite sample that's been collected over a period of time. So that's the difference between a grab and composite sample when it comes to water samples. Maybe you have a scale sample. And a scale sample, let's say, for example, a customer has opened up a boiler and you find some scale. Well, now it's very important not just to collect that scale to send off to the lab. And I think that is important. But it's also very important to collect all of those context clues around that sample so you have that data when the report comes in. So I love to take pictures of where I'm collecting that sample. And I love taking pictures of all around. Of course, if you get inside a boiler, why not take as many pictures as you can? Because we do not have that open to our benefit very often. So we need to collect as much data as we can. Even if there isn't a problem, I still love taking pictures because that allows us documentation for future inspections. So I always want to take a picture of what I'm taking the scale off of and what is around it. I'll then come back and I'll try to get more, say it's on the top of the piping or it's on the bottom of the piping, wherever that is. I want to make sure that I have reference in photographs. So that way, when I get the report back, I can do some more analysis based on all the contextual information that I gathered when I collected that sample. That is so, so important. And I can't tell you how many people have asked me to interpret lab results, and I don't have that information. I want to know where the scale sample came from. I want to know what was around it. I want to know what pipe it was on. I want to know how many other pipes were around it. Maybe it was a cross section of pipe in a system where they had corroded pipe. I want to know where that was taken from. I want to know what was around that pipe. Of course, a water sample, especially if we're not getting what we need out of that water sample, maybe we predict that there's going to be no iron. It comes back with just an astronomical amount of iron. Well, maybe we didn't collect that sample right. But if we backed up, took pictures, and we can look at how we took that sample without going on site, we can troubleshoot what the analysis is telling us. So with all of that, I hope you realize it's not just collecting that sample. It is collecting all the data around that sample because, as a good friend of mine likes to say, chillers can't talk, and either can any of the other equipment that we are charged for treating. We've got to get as much information as we can when we can so we can interpret what is going on for that heat transfer equipment because they can't talk to us. They can't talk to anybody else. We are now their faithful translator. And now maybe we can change our water treatment program to help with whatever's going on. Maybe there's a mechanical issue going on, and we can now be the liaison between the mechanical company and the owner of the equipment so they understand why something needs to be done. We might need to be able to talk with the financial people of the company because they don't understand why they need to invest all of this money to repipe this system. And now we can explain to them how this is costing them money. And eventually they're going to be able to make whatever money back that costs them to fix the problem. And that's going to be a return on investment. And that is always an easier conversation to have when you have pictures, when you have notes, when you can take somebody who's sitting in an office into the mechanical room or wherever the problem resides, and you can say, this is what we're talking about, this is what needs to be done, this is why it needs to be done, and this is why this is the best decision. You will get people to be able to help themselves because you've got all of that data. I have never regretted having too much data when I've collected a sample. However, I have regretted not having enough data and then having to piece together why a sample came back from a lab a certain way. And I had to go back on site, and maybe I did not have access to all the things that were open, like the boiler we were talking about. So nation, with all of that, collect all the data that you can when you can. And for the data that you're not even thinking of, take some pictures because it's amazing when you get data back from a lab and you have a picture how you're able to piece things together. Another question from a Scaling Up Nation member is, what's the difference between quantitative and qualitative? And I know these terms are used all the time in testing, and I've even heard them used interchangeably. Let me assure you, they are not interchangeable. So let's go ahead and define them. So quantitative refers to the measurement or the analysis of the amount or quantity of something. So simply put, it's the numeric value of something. Now, qualitative, on the other hand, pertains to the characteristics, the properties, the qualities of something. So now you've got those two definitions, and with those, you can use those terms properly. Another Scaling Up Nation member is asking about different labs they send to. They all have different procedures, and they want to know why that is. Well, the answer is that's their procedures, and they get to have their own procedures. I really don't know why different labs have different procedures for the same testing. I can tell you that we have a lab here. We do corrosion coupons for different members out there in the water treatment community. And we have a set of procedures that we've put together because we know if we ask people to follow these procedures, it makes our process easier. It lessens the mistakes potentially we could have. It allows us to get the information that we need so we can do the best job possible. So why are the procedures different between Lab A and Lab B? Well, probably for those same reasons. So let's just say that they have our best interest in mind with those procedures. We need to know what they are. So the first thing that we need to know, and I mentioned this earlier, is how should we be collecting that sample? And of course, there's all types of samples. In this case, let's say we're talking about a water sample. So does it need to be in a special container? Does there need to be some sort of pre-treatment in that container? Does it need to be taped? A lot of labs like to get things in with electrical tape around the edges of the top and the bottle. And that's a good practice anyway. It keeps it from loosening in transit. And if you leak out all your sample in transit, you're not going to be happy with the results of an empty bottle at that lab. So that's something you can do. Some labs require it, so just be aware of that. And then how are you going to send that? So when you send a lab sample, when is it going to arrive? And how is it going to be sent? Is it legal to be sent the way you are sending it? So if you are using the United States Postal Service, they have certain things that are acceptable to mail and certain things that are not. So you don't want your package to get confiscated because it was not proper to ship, because then you're not going to get your results. Now you might be using FedEx or UPS or one of the other companies. They have certain things on how they want things shipped. So make sure you know you're shipping those things properly. Liquids can leak, so normally there are special stipulations around that. So make sure that you know those. But in addition to knowing the processes that the companies want for you to ship, when is the lab going to receive that? Now, if you ship something UPS, normally it will say this is 2-day service or 3-day service. Okay, well, if today is Wednesday, then they're going to get it on Saturday. Wait a second, there's nobody at the lab on Saturday. Maybe I don't need to collect my sample today. Maybe I need to wait until Monday, go out and collect my sample, and now the lab can get it. And as soon as they get it, they can start to process it within their system. A lot of labs might charge you an extra processing fee if somebody receives it on an off day. Or maybe if they receive something on Friday, they don't process those certain tests on Friday because of the time that it takes. Whatever the case is, you need to know what the procedures are, not only for collecting the sample, but also getting the sample to the lab. We have several labs that we use that we know we can only give them samples on certain days of the week. And then if we cannot get them on those certain days, we either need to travel to the lab and physically hand off that sample or wait until another day when we can mail that to them or ship that to them. So that's very important. And so many people don't think about that. And they might now have a sample that something needs to be done within a certain amount of time of the lab receiving it. And it's just sitting, waiting to be inventoried when somebody comes in on Monday, Friday night, Saturday, and Sunday. So make sure you know all the things that the lab needs you to do before you send that off. And with all of that, you will have a much happier time with the lab. I can't tell you how many people that I've worked with that get upset with the lab because they didn't follow procedures and now the lab is calling them on it. People, the procedures are out there. The procedures are there to help you. And I know you're in a hurry going from account to account and helping all of your customers. And you probably don't think you have time to call the lab and ask them, what do I need to do to send this sample to you? I promise that 3 minutes on that phone call will save you a tremendous amount of time. And what we like to do here at our office is create procedures for everything that we send off so we don't have to make that phone call again. We now just print off the procedures, we go out, we collect the sample, and we know we are doing it right. Now, that being said, Lab B is going to be totally different sometimes from Lab A. So don't assume that every analyte that you are asking to be tested is going to be the same way. They might have different receiving hours. They might have different ways they want to receive that. They might have different containers that's in. So you probably have to do that for each and every lab. But I promise you do that once, follow it, the lab will love it, and you'll love the results from that. Another member of the Scaling Up Nation wants to know, can we run tests from our test kit so we don't have to send samples to a lab? Well, the answer is yes, but they're going to be a little bit different. So as we talked about before, you're going to get more quantitative samples from the lab because they're going to give you numeric values of what's going on within that sample. Now, you're not going to be able to get precise numeric values when we're working out of our test kit with, say, a scale sample. But we can use things within our test kit to give us some qualitative looks at that scale sample. And then maybe that might allow us to make some changes to our program while we're waiting for the tests that we're sending in. So let me give you an example of that. Let's say that we have a boiler inspection. The boiler is open. I love it when boilers are open. I love it when chillers are open because we get to see inside what our work is doing. We get more data so we can apply that data to make our program even better. So in our case right here, we have a boiler that is open. Let's say for fun, it's a fire tube boiler. And we see that there's some scale in that. And we want to go ahead and send that off to the lab so we can determine what is in that scale. And then is there anything that we can do to augment our program to start cleaning that scale up so we don't see it next year? So we go ahead and grab our sample. We do everything that we talked about in the beginning of this podcast by taking our pictures, getting all of our context data, and we go ahead and get that ready to send off to the lab. Well, maybe the lab is back ordered. Maybe it takes 3 weeks for that sample to be run. We could actually start doing something within that 3-week period if we knew a little something about what was in that scale. Now, this is just one example that comes to mind, but there's dozens that you can do in your test kit. But let's say if you were trying to determine maybe if that sample was calcium carbonate. So find a flask, go ahead and put a little chip of scale within that flask, and everybody should have a alkalinity titration kit. Well, your titrant is sulfuric acid. Now, I know there's all sorts of different strengths of sulfuric acid out there. We're not going to get into that. We're just going to say it's sulfuric acid. Go ahead and put a couple of drops on the scale sample that you just put in that flask. And if you see it start to bubble up, most likely, again, this is not an exact science, but most likely that is calcium carbonate. And you can say, okay, well, we just liberated some calcium carbonate, so I know a little something about that scale sample. Maybe we want to take that a little bit further. and we put a little bit of DI water into that flask, and then we test that water after we agitate it a little bit for iron, and we get a number of iron. Now, it's not going to be a real number. It's just going to be a characteristic number that, yes, iron is in there. And we can do that with pretty much anything that you want. It's not telling us exactly what is inside that scale sample in quantities, but it is telling us what that scale is made up of. And now maybe we have something that will allow us to start to disperse that on site. Maybe that's part of our product line, and we can just simply turn something up. So now in that 3 weeks while we are waiting for the exact sample to come back, we've done something within those 3 weeks. Now we know exactly when that report comes back, things that we can do, and now we're back on site. And if we test our boiler water, we can probably find the things that we found in our scale sample are now liberated in the boiler water, letting us know that we, in fact, are liberating some of those things that we found in scale. And now we have a laboratory analysis of exactly what was in that scale. So don't wait to do something until the analysis comes back. Now we have 3 weeks of that product starting to work on the system, and we have our data telling us that what was in the scale sample. So that's one way you can use your test kit. Of course, there are dozens of ways to do that. And you say, Trace, I want to test for this, not iron. Well, okay, use the same method that we just talked about. Now, that's called a wet analysis, and it is a good guess. And let me tell you, in water treatment, that's all we do is scientific guessing, and then we use the data to back it up or prove it later. So that is one way that you can use some of the chemistries within your test kit to give you a head start on however you want to augment your water treatment program. Now, I'm pretty sure I've answered this next question before, but I'm going to answer it again. And we talked about it earlier in this podcast. It's the little blue tablet that is in a Legionella test. Why is it in there? And do you have to leave it in there when you're taking your sample? I mentioned this earlier, but again, when you're taking a Legionella sample, you want to know what Legionella bacteria is in the sample the second you collected it. Now, if you just fed oxidizer and there is active oxidizer within the sample and you didn't neutralize it, and that's what that little blue pill does in the bottom of that sample, as it's in transit, that oxidizer will kill whatever bacteria is there, and you're not getting a representative sample. So whether it's the blue pill in Legionella or another type of reagent or another type of pre-treatment, you want to make sure that you keep those in your sample. And Nation, when you're doing Legionella tests, remember you want to know what is in the pipe at the time of access when that person is turning on the faucet. So that allows the lab to do that. And if you are interested in learning more about Legionella testing, we've done several shows on that, and you can go to scalinguph2o.com, go over to our search bar and just search whatever you're looking for. And we've done so many shows on Legionella. The Scaling Up Nation really enjoys learning more and more about Legionella. Speaking of that, we're going to have Legionella Awareness Month coming up in August once again this year. Those are some of our most popular shows. And Legionella has been around for a while. There's not that much new in Legionella, but the nation loves learning about it. And I love bringing information to you because that means we are doing something about it. We're using that information. We're able to talk to our customers and let them know what they need to do as owners of this equipment and get them better data. So whether you're looking for Legionella or another topic, going to the Scaling Up H2O website and searching whatever you're looking for. Every single podcast has a transcript. We do that so that way it is searchable. And it is amazing after 300 plus episodes, all of the content that we have on industrial water treatment and all things water treatment. So if you're looking for something, most likely you are going to find it there. Nation, our last question comes from a Scaling Up Nation member that saw my math presentation at the Association of Water Technologies. And during that presentation, I teach how to manipulate your titrants. So if you want to get them to, let's say, a lower number for your testing, you can do that by manipulating the sample size. Now, here's the perfect example of that. Let's say you are testing nitrite, and maybe you're doing a system sizing. So you don't just need to know that there's nitrite in there. Say you've added some nitrite to size the system, and you want to try to get it as accurate as possible. But you know that 1 drop equals 50 of your titrant. How can you get that a little bit tighter? Well, I'm going to give you a formula, a mathematical formula that you can use with any titration, and this will change the quantity that you assign to each drop based on whatever your volume is. So the first thing you need to know is the procedure for your test. And in this case, let's say it is a can nitrite test, and you are using 1 drop equals 50 parts per million of, let's say, sodium nitrite. And by the way, that is very important. Is it nitrite? Is it sodium nitrite? What species is your test looking for? Now, it's going to be the exact same reagent, but you had a chemist back in the lab where that test kit was built that calibrated that titrant to offset for what species you are looking for. So don't assume just because it's the same juice that it's going to have the same output. You need to know what species you're looking for. So in this case, let's say it's a sodium nitrite test, and 1 drop equals 50 parts per million. So what we now need to know is what the original sample size is. And let's say the original sample size is 5 milliliters. Now, everybody knows this test that we're talking about. And then what we want to do is we want to increase the sample size, let's say up to 50. So here's what we know. If we just run the test as normal with 5 mils of sample, that titrant is going to tell us every 50 parts per drop of what's in there of sodium nitrite. But now if we take it up to 50 volume is our new volume size, what's the drop count going to be? Or what are we going to multiply the drop count? So here's our math equation. We go ahead and take our standard ppm drop count, which in this case is 50, and then we're going to divide that by what our new volume is divided by what our original volume is. So in this case, our new volume is 50 mils, and our original volume was 5 mils. That's going to give us 10. So we're going to divide our 50 drop count by our volume of 10, and that's going to tell us that our new drop count is 5. Well, folks, that's a nitrite test, but it works on any of your titrants. So real easy equation. You can do that wherever you are, whenever you need that. And there's so many reasons that you might want to manipulate what your drop size is or what the count of the drop is. So that way you might be doing a system sizing. You might be doing some sort of an analysis, like we were trying to figure out what is going on with the system. Now you have the data to do that. And Nation, it is all a gift from math. And Nation, you all gave me a gift today because you called in, wrote in, texted in, did all the things that you do with your questions. And without your questions, I would not have a show today. So I want to thank you for all the people that gave us some questions so we could create this show. And I tell you, it's always fun to take a bunch of different questions. We took about a dozen questions today, and we just contoured a show around those questions. So I hope this was helpful for you. I hope that the next time you are doing whatever test it is, when you're sending that off to a lab, you're thinking about it a little differently. You've got your procedures and you know what to expect before you actually take that sample. I know it's going to save you time. I know it's going to help you in the long run. And I know it's going to make you a better water treater. Somebody that's trying to help us be a better water treater each and every week is our friend James McDonald, and here's a brand new Drop by Drop with James.
Welcome to Drop by Drop with James, the podcast segment where we wonder, explore, think about, imagine, and learn industrial water treatment. You guessed it, drop by drop. Together. In today's segment, I have another challenge for you.
Challenge accepted.
Today's challenge is draw a process flow diagram for your water systems. Having a good process flow diagram will help both you and your customer. The exercise may correct some assumptions you have or open your eyes to challenges you never knew existed. Be sure to include chemical feed points, water meters, blowdown lines, valves, waste streams, pretreatment equipment waste streams, boilers, cooling towers, chillers, closed loops, dead legs, pressure and temperature gauge locations, pH probes, controllers, heat exchangers, makeup lines, outfalls, and whatever else you may run across. Feel free to make notes about frequency of equipment rotation, flow rates, temperatures, pressures, etc. Lastly, hand-drawn diagrams can be just fine because any process flow diagram has got to be better than no process flow diagram, right? No need to get fancy, that would just slow you down and prevent you from making process flow diagrams in the first place. I'm James McDonald, and I want to encourage you to be like water by forming bonds with those around you, dissolving new knowledge, and making worthy ripples, drop by drop.
Thank you, James. And once again, thank you to all the people that wrote in with their questions. I know you've got a question out there, so don't keep that to yourself. Let us know what that question is. Who knows? We might put that together with other questions and make a whole new show. But the only way we can do that is if you let us know what your questions are. You can go to scalinguph2o.com/show ideas. And we've got a form that's real easy to fill out. We'll get that data, and that will be our next show. Nation, I love bringing shows to you, and we're going to have a brand new one for you next Friday. Until then, take care, folks. Scaling Up Nation, one of my favorite things to do is teach and coach people. I wanted to make video content that would help water treaters gain the confidence they need to take the next step in their career. And that is taking your Certified Water Technologist examination. If you've been in the industry for 5 years and are ready for the next step in your professional career, sign up for my CWT Practice Exam course. The course has over 130 videos to help you take and prepare for the CWT exam. Don't delay. Visit scalinguph2o.com/CWT prep to sign up for my CWT practice exam course. Again, that's scalinguph2o.com/CWT prep. I'm here to help you gain the confidence you need to take the CWT exam.